None of the students has joined. This is very bad. I've been waiting for so long. Actually, you should wait, na? I can't just simply wait for you. Only three has joined. Four. Regular in class. Not the way. Okay. So maximum of you have joined. So let us start. So now today we'll in the last class we discussed about the syllabus. I hope every one of you have taken a note of that. Yeah. Have you taken a note of that? Hello. Hello. Has everyone taken a note of that? The syllabus. Hello. Can you hear me? Can everyone hear me?
Yes, sir.
So have you taken a note of the syllabus? Have you taken a note of the syllabus? Someone respond.
Yes, sir.
Okay. So let us start the class. Okay. So first of all, what is engineering mechanics? Engineering mechanics is it is one of the most basic subjects that is required to study. Like this is for civil engineering. Okay? Hmm. So this subject will expose you to what concepts like friction, kinetics, kinematics, then resolving forces, passes, etc. Okay. Like this engineering mechanics subject will give you a brief exposure, right, on different subjects. Like these are the topics that. Okay. So these are basically required to study for the basics concept of engineering mechanics. Okay. Now, these uh, concepts will be used in different subjects and structures. In every subject basically, civil engineering, engineering mechanics concept is required. Now, you just can't deal with any other subjects without knowing the basic concept of this. Basically, all the subjects are the application of this. Okay. Now, if you can see introduction, just go to a bit more detail. This mechanics is a combination of physics and mathematics that are concerned with the behavior of bodies that are acted upon by force, which deals with the state of rest or the state of motion. Okay? So there are, in engineering mechanics, if you see this flow chart, you see this flow chart, so here you can see that in engineering mechanics, there are different parts. Number one is what? Fluid mechanics, and solid mechanics. That is basically divided into fluid mechanics and solid. The solid mechanics means the mechanics which deals with the motion of solid objects and bodies, and for fluid it is something which is in motion or like something which is fluid. So now this is divided into what? It is divided into statics and dynamics. It's fluid part. Then in solid mechanics, it basically we have the mechanics of rigid bodies, then mechanics of deformable bodies. Okay. Now after that, you know, we have different sub-parts on it, like strength of materials, theory of elasticity, theory of plasticity. Then mechanics of rigid bodies are divided into statics and dynamics, which complex dynamics is divided into kinetics and kinetics. Now, this part, the solid mechanics, yeah, this part, related to this, the theory is related to this, the basic concept of this part in the engineering mechanics, we will be studying in this semester. And in the next semester, we'll be having a proper solid mechanics subject. Okay. Now, this fluid part will be, I think so, maybe in this semester or next semester, it will be taught in the upcoming semesters, this fluid mechanics part. That is related to fluid or flowing bodies. Okay. Now, let us go through a few definitions. I hope all of you can see my screen. I hope all of you can see my screen.
Yes, sir.
And my voice is clear, I think so. My voice is also clear, I think so.
Yes, sir.
Okay. So, first of all, what is statics? Okay, what is statics? So, statics is when the force system acting on a body is balanced and the system has no external effect on the body. The body is in equilibrium. Means what? Force. Suppose this is a body. In this body, there is no external force. No external force acting. Then this body is defined as statics. Okay. Now, suppose this body is having some external forces which have been acted upon, like this arrow depicts here. This arrow depicts the external forces that are acting on the body. Okay. So now, if these external forces are acting on the body, then what will happen? Then this part is called the. It will have some effect, right? So that effect in that study is which a kind is timeless of dynamics. So that means what? This is the branch of engineering mechanics in which, suppose this is in this object, there are certain amount of forces which are being acted upon. Okay? Now, if these forces are being acted upon in this body, then what will happen? It will have some effects on it, right? Now, suppose someone pulls you, someone pushes you, then you generally tend to fall down, right? If you tend to fall down, then you are having some effect because of that force. So that part is, it, that part, very dealt by what? This dynamics part. Is it clear for everyone? Is it clear for everyone? Is it clear for everyone?
Yes, sir.
Okay.
Yes,
Now
yes.
we have what? No, we have kinematics. So kinematics is what? Kinematics deals with the geometry of motion of bodies, which without an application of external forces. Now this kinematics is what? Suppose let me give you again the same example. Let me give you the same example of this problem. Now here in this body, you are having external force is acting on this body, and this body is in what? In motion. Now here, if the body is in motion, there are two cases. In one case, external force is active, and in one case, there is no external force. Only the body is moving. Hmm. Now, if the body is moving without any external forces, then this is called what? No? This is called uh, you know, kinematics. Okay? And this body is moving, and external forces are being obtained upon it. Look, motion of bodies with the application of external forces. That means that this body is moving, and external forces are like acted upon it. Ah, and also, this body is doing what? Your motion. Then this is called what? Kinetics. Is it okay? Is it okay?
Yes, sir. Yes, sir.
Okay. So these are the basic concepts. Now, particle. What is actually a particle? So particle is defined what? As an object which has only mass and no size. एक particle का क्या होता है? The particle has only mass, it's got its own mass, but definitely it has no size. That is why the definition says a particle. The definition. Now, rigid body. So rigid body means what? Again, you just draw this object. This object has what? Suppose it has a mass m. So it is having certain amount of mass. Yeah. And suppose it has L length and V breadth. That means what? It's having some definite size and dimensions. Yes or no? It is having some definite size. But this kind of hmm, this kind of body is called a what? Rigid body. Now, in rigid body, the relative portion of any two particles do not change under the action of force. In rigid body, what happens is that the relative portion, the body of any two particles does not change under the action of forces. Okay, that means if some force is applied on this body, the relative portion of this body, is not going to change. That's it. Okay. So I hope everyone is clear about it. If you have any doubt, you just can ask me to this part. Then I'll move on to the next part. I'll wait for some minutes. Oh, if you just tell me, ask me for any doubts. I'll give you 5 minutes. Just try to revise it and just small these definitions. Then, if you're having some doubts, you just ask me.
Hello, sir. Hello.
Yes.
Sir, please repeat the
Which part?
kinematics. Kinematics.
Okay. Kinematics and which one? Tell me. Kinematics. Only kinematics.
Yes. Yes, sir.
Suppose, suppose what happens? I'm giving you an example. Okay? Now, suppose our body. Body means what? Suppose anything. No. Suppose a block of wood. Okay? Now, a block of wood is moving. And look, when you try to move a block of wood, or maybe a table, when you try to move a table, you generally what? Push it with your hand, right? Yes or no? Yes or no?
Yes. Yes, sir.
Okay. So if you push it with your hand, that means what? You're applying certain amount of forces on the table because of which it is moving. Yes or no?
Yes. Yes.
Yes. So now,
Yes,
because
sir.
of that force applied by you on the table is moving. That means what?
Yes.
Because of certain amount of external forces, which is you that is applying the force on the table. That means the body is in motion, right?
Yes.
Right or no?
Yes.
Now that part is known as kinetics. Now in kinematics, what will happen? Suppose you just assume it hypothetically. The table
Mm.
is the table is in motion, but
Mm.
you are not applying any force. If you think
Okay.
that the reverse of that, that means you are applying force, that is kinetics. If you are not
Okay,
applying
sir.
force, but then the body is in motion, huh? Then
Mm.
it is what that is called kinematics. Now is the concept
Yes,
clear?
sir. Yes, sir.
Okay, that is the giving a practical example. Yeah. What about others? Anything else you have to ask?
Hello, sir.
Yes.
Is there any exception where rigid body also can change
I can't
their
hear you
shape?
properly. Can you please be a bit more clear?
Sir, I'm asking about rigid body. Is there
Okay.
any
Yeah.
exception where rigid body
মই শুনা নাই
can
তোমাক তুমি please be clear I'm not
change
able to
their
hear তোমাৰ voice to clear your voice is not clear actually breaking can you please be more a bit be clear a bit I just heard his voice clearly just move to some other location and speak more clearly in rigid bodies what you are saying just say now you can do one thing you can just type it in the chat box if you are not able to if I'm not able to hear you just type it in the chat box whatever you do so is there any exception look if the body changes their shape, then definitely it will contradict the definition of rigid body itself, right? Gerardin, you understand me what I'm saying? Suppose on application of external forces that body is changing their shape, then that whole concept of rigid body is altered. So definitely there is no exception here. If it is rigid, then it doesn't get it has definite mass and definite size. Okay? Is it clear now?
yes, sir, yes.
Okay. Good. So basically, what I'll do is, for textbook purposes, I just gave you a link of textbook in the last class, I think so, if I remember. If I remember, I just give you a link of the textbook. Did you get the link of the textbook? Hello? Hello? Can anyone say? I just gave the link of the textbook in the last class. Okay, leave it. If you need it, I have a PDF of the engineering mechanics book by Kurmi. Just give me a message if you need it. I'll send it to you. Or maybe we give it in the mentor group. Just do one thing. Give it in the mentor group if you need it. Okay, I'll just send you the PDF there. Give you a message in the mentor group if you need it. Okay, so now let's just move. The next definition is fundamental units. Okay, so what is fundamental units actually? The measurement of the measurement of physical quantities requires what? Some internationally accepted units, right? That is called fundamental units. Now, suppose I'm just giving you a example. Suppose the length. No, suppose the length of a particular scale, long scale is how much? It is 30 centimeter, right? Yes or no? How much is the length of a long scale? Can you tell me?
Sir, 30 centimeters.
Yeah. So the length of a long scale is 30 centimeter. Now, suppose if there is no common unit, what will happen? Someone will write 30 something, someone will write 30 something, but the measurements will not be uniform, right? So that is why a fundamental unit is necessary always, which is accepted internationally. Now all physical quantity, that means length, mass, time, everything, these are basically measured or expressed in terms of three fundamental quantities. That means that if you see every unit, it has got some relationship with this length, mass, and time. Okay, it has got some relationship with this. Now, okay, so now hmm, this length, mass, and time. Can you give me an example of units of length, mass, and time? Yeah, can you all? Someone else from your group, just say, give me units of length, mass,
Sir,
and time. Yeah,
meter,
you say one.
kg,
Okay, length is
second,
meter.
meter kg
Then
Second.
second,
hour
okay, good. Meter,
second.
kg, second, hour, everything. So
and
these actually, if you see, every unit, these are basically derived from what? If is meter is there, or kilogram, or gram, something like that. Meter, centimeter. Huh? Then for time, second, minute, hour. So all units are basically expressed in general in this form in general. Do you agree with me? Yes or no?
yes, sir, yes, sir.
Okay. So from these physical units, from these basic units, there are certain units which are derived from these physical units. Okay. So these physical units which are derived, they are known as the derived units. Now, derived units, I'm just giving you an example. First of all, the unit of area. Area is what? Area is length into breadth. I hope every one of you know. Area means what? L by B. Yes or no?
Yes, sir.
Yes.
So length into breadth means what? Suppose the unit of length is in meter, breadth is in what? Meter. Then we are having it what? Meter square. That means what? This unit meter square is basically derived from this meters. So this is the unit of area. That means what? This is called the derived unit. Yes or no?
Yes, sir.
So similarly, velocity, acceleration, these are all what? Derived units. That means the main unit is a different unit. Then you have derived it. Like in velocity, how much? Meter per second, or kilometer per hour. So this is how you derive this units, right? So these are called what derived units. Is it clear? Is it clear?
Yes, sir.
In the system of units, there are different system of units: CGS, FPS, then MPS, and SI. In SI unit, this is what is being followed, okay, in this book. Okay. And in basically the SI units are always followed. Now SI full form is system information. Okay, these are the SI unit, formulas and derivations. Simple. Okay, so we will discuss this in detail because you all know, I think so. What is SI unit? What are different SI units? Yes, yes or no? Hello? Yes or
Yes, sir.
no?
Yes, sir.
Okay,
Yes, sir.
okay. So just ask me any doubts if you have.